Diabetes mellitus, also called as diabetes. Diabetes is a chronic metabolic disease with high blood sugar level, also known as hyperglycemia. There are generally three types of diabetes. The first is type 1 diabetes. Type 1 diabetes having insufficient insulin production require daily injections. And type 2 diabetes having impaired insulin utilization can cause nerve and blood vessel damage. And lastly is gestational diabetes. This type of diabetes having high blood sugar during pregnancy. The common symptoms of diabetes are frequent urination, thirst, hunger, fatigue, blur vision, infections, slow healing bowels, weight loss, tingling, or numbness in extremities. Diabetes is now a global major public health concern, and the number of adults with diabetes has nearly quadrupled since 1980 to 422 million. Rising risk of type 2 diabetes due to overweight and obesity, and also 30% of cases are detected early due to unclear symptoms. Delayed diagnosis can lead to heart disease, stroke blindness, kidney failure, and limb amputation. Long-term high blood sugar can damage nerve and blood vessels, increasing the risk of cardiovascular issues. There are 9 million people with type 1 diabetes in 2017, mostly in high-income countries, and also increasing prevalence of type 2 diabetes in children. Women with gestational diabetes and their children at higher risk of type 2 diabetes. The main goal of this research is to develop a binary logistic regression model to predict diabetes. We're also trying to identify key risk factors such as age, BMI, or blood pressure, and also predict diabetes-related complications, for example, cardiovascular disease and neuropathy. Last but not least, to provide information for prevention strategies and proactive management.
Following is related words. For the variables, they are independent variables which are number of types pregnant, pregnancy, glucose level, blood pressure, skin thickness, insulin level, body mass index, BMI, diabetes pedigree function, and also age. And it can predict the dependent variable which is diabetes status outcome. The following is statistical method. Based on the 5 related articles, the common statistical method they utilize for diabetes prediction is binary logistic regression. They predict the probability of dependent variable which is diabetes status outcome by using other independent variables. So for the statistical method, the trend test split were used by Guardian M, NetName, Buller, and Gibbs for Kids. The given initial dataset will be split into a training dataset and test dataset. The training dataset will be leveraged to build the most fit and accurate logistic regression model, while the test dataset will be used on the testing predictive accuracy of the trained model. On the other hand, Rajendra and Latifi used to have data pre-processing, data selection, and feature evaluation in the earlier stages of binary logistic regression approach. This ensures that the most relevant and significant features are included in the model, enhancing its predictive power. Next is findings and objectives. These 5 articles evaluate the outcome of performance of their model using evaluation metrics such as accuracy and AUC score. For instance, Guardian reported an accuracy of 85% for their logistic regression model, indicating high precision and recall. Similarly, Rajendra and Latifi achieved an AUC score of 0.989, showcasing the strong discriminatory power of their model. The objective of these studies is to develop a reliable model for predicting diabetes by accurately identifying the relationship between the dependent and independent variables. Finding from Gardner and emphasize the importance of including family history and blood pressure as critical predictors. This finding therefore underscore the importance of selecting relevant independent variables and highlight the potential for logistic regression in effectively predicting diabetes risk. The following is data. First, source of data. The source of data is the Payment Indigenous Diabetes Database, which is sponsored by and published by the National Institute of Diabetes, Digestive and Kidney Disease (NIDDK) in the United States of America. This dataset is publicly accessible on the KECO website. This dataset comprises records of female patients from the Pima Indigenous community. So this is the data description and visualization. As we can see, this dataset contains a total of 9 columns and 786 rows. Each rows representing a female participant from the Pigma indigenous community. The purpose of this dataset is to capture the diabetes stated outcome from each female participant based on their pregnancy, glucose level, blood pressure, skin thickness, insulin level, body mass index, diabetes pedigree function, and age. The dataset shows a binary outcome for each female participant, specifying whether the individual is non-diabetic or diabetic, either 0 or 1. As you can see, the pregnancy, age, and outcome data types is integer, while other is float.
For statistical and data analysis method, what is binary logistic regression? Here's the model, the relationship between independent variable and outcome variable. The outcome variable takes two possible values, 0 and 1. So why we choose binary logistic regression is classification problem with most dependence variable. It also can explain the mediator binary outcome relationship through pulse radio. What is the advantage binary logistic regression is can extend the two interactions terms and polynomial terms for modeling complex relationship. So how to use binary logistic regression to address the objective? The first one is the key point interpretation of coefficients. The second one is risk factor evaluation. Third one, forecasting complication. The last one is model evaluation. So we also check the data pre-processing. So first we check whether any duplicate row. There is not any missing value in between rows, so we don't need to require to remove them. So the third one is handling outlier. We prevent outlier function and features and link from altering target variable value. We also create a 80% test train data from the dataset and 20% train test data from the dataset. In EDA, we first use code head data to display the first 6 rows of dataset. So the second structure of the data is contains 768 observation and 9 variables. The summary statistic is also show the mean, max, mean, median quantities. The size of the training dataset is 640 rows and the testing dataset is 184 rows. So we also create the props histogram and box props for numerical features. So the box props also using the IQR and medians to provide a clear visualization of central tendency and variability. So the box prop also contain 0 is for non-diabetes individual and 1 for diabetes. So in this schema, we also show the color indicate intensity between pair of variable. The dataset heat map and correlation metric reveals strong correlation between glucose, ensuring skin thickness, indicating metabolic risk. However, weaker correlation with BMI, diabetes, degree functions suggest less direct roles. This information can guide further analysis and inform intervention. So 4.4 information on data analysis process. First, we fit the logistic regression model using the GRM function using binary target as outcome variable and all test data columns as predictor. The second is generate a model summary including coefficient, standard error, z-value, and p-value to assess predictor significance. The third one is generate predict probability using the predict function, classify outcome and into binary category. The fourth one is create a variable called true for label to compare prediction with actual outcome. The five is create a confusion metric to evaluate performance. The sixth is calculate accuracy by dividing the sum of correct prediction by total prediction. The last one is conduct using the ROC function to plot the curve and calculate the AUC.
The result of the model summary of binary logistic regression indicates that glucose, BMI, and diabetes pedigree function are the key significant predictors, as high level of these variables are associated with a greater likelihood of the outcome. On the other hand, pregnancies, blood pressure, skin thickness, insulin, and age do not show significant relationship with the outcome, suggesting they may not be critical in this model. The null deviance, which is 199.54, compared to the residual deviance, which is 138.81, shows that the model explains a significant portion of the variability in the outcome. Moreover, a AIC value of 156.81 indicates a good balance between model fit and complexity. The confusion metric has 84 true negative, which the model predicts negative correctly, 21 false positive, which the model predicts positive incorrectly, 16 false negative, which the model predicts negative incorrectly, and 33 true positive, which the model predicts positive correctly. The model has an accuracy of approximately 76%, which is calculated by dividing the true negatives and true positives by the value in the confusion matrix. It indicates a reasonable performance from the model. Based on the graph, the ROC curve lies significantly above the diagonal line, indicating the model is performing better. The steep initial rise also indicates that the model has higher sensitivity for lower false positive rates. The model has an AUC value of approximately 86%, which is calculated from ROC curve. It indicates that the model has a good level of predictive accuracy and can effectively differentiate between positive and negative cases in a dataset. So the model A is results from reader works and model B is result based on our model. Both summary model results suggest that glucose, BMI, and diabetes pedigree function are the key significant predictors, while pregnancy, blood pressure, skin thickness, insulin, and age are not. We can interpret that model B fits the data better with lower null and residual deviance and lower AIC value. This is the result of the accuracy and AUC value of both models. Model A has higher accuracy with approximately 82% and AUC value with approximately 89%. Despite the statistical data suggesting that the model A has an age, the result of both models has a similar pattern in terms of accuracy and AUC.
A limitation of this research, representativeness might be a crucial problem, because this dataset all comes from female at least 21 years old of Pima Indian heritage. It might not represent the entire population, which may lead to biased result. For example, if the sample consists primarily of individuals from a particular demographic group, the model may perform poorly in other groups. Another limitation is limited features. The predictive power of a model depends heavily on the features included. If important predictors of diabetes are ignored, the model's accuracy will be impacted. The feature study can be focused on larger and more diverse samples, enhance the overall applicability of the results by conducting research with more diverse and large samples. Through analyzed participants from diverse demographic and socio-economic backgrounds can help create a more robust model, thereby increasing the accuracy of predictions. In another way, improved features engineering is also a concept of feature study, involved in advanced feature engineering, such as developing iteration terms and polynomial features to capture intricate relationships between variables, greatly improve the accuracy of prediction results. Other than that, there are also advanced predictive models. Investigate the applications of advanced machine learning methods such as random forest, gradient boosting machine, and neural networks to improve the accuracy of prediction and solve nonlinear relationships. So in conclusion, in this research, our purpose is to use binary logistic regression to predict diabetes focusing on demographic, clinical, and lifestyle factors, and also develop a statistical model for accurate diabetes predictions and identification of significant risk factors. So we apply logistic regression to the PIMA Indian diabetes datasets and also identify abnormal glucose levels, BMI scores, and age as significant predictors. We get a result coming out consistent with previous studies, and these variables are essential for predicting diabetes. And we find out the need to include multiple variables for high predictive accuracy. Findings are useful for designing targeted preventive measures and early management for high-risk patients, and also enable timely medical interventions, reducing the overall burden of the disease. And the future work can incorporate more complex models of machine learning methods for better predictive accuracy, and also focus on using larger and more heterogeneous datasets with additional risk variables to generalize predictions.